Hello everyone. Continuation of virtual clusters and resource management. This concept we have discussed in a live virtual mission migration steps and performance effects. Here we can see the migration copies the virtual mission state, what the file from the storage area to the host mission. Now we can discuss this diagram, this figure in a clear cut way. Listen carefully. This figure illustrates you that live migration process of a virtual mission from one host to another. Here we can look at this diagram. All of you, virtual mission running normally on host A. At stage 0, the pre-migration active virtual mission on host A, it should be alternate physical host may be pre-selected for migration block devices. It should be mirrored and free resources should be maintained. And coming to the stage 1, it should be reserved, in the sense reservation, in the sense to initialize a container on the target host. Okay, we can see the overhead due to copying that at stage 2, iterative, in the sense iterative, repeated the pre-copy to enable shadow paging and copy dirty pages in successive rounds. At downtime, the virtual mission out of service, at stage 3 we can define stop and copy. It should be suspend virtual mission on host A to generate address resolution protocol to redirect the traffic to host B, to synchronize all remaining virtual missions state to host B. At stage 4, we want to do the commitment. Virtual mission state on host A, it should be released. And coming to the final one, virtual mission running normally on host B, at stage 5 it should be activation. The virtual mission starts on host B, it connects to local devices, resumes to normal operation. That is the process of live migration of a virtual mission from one host to another. It is a step by step process at stage 1 to at stage 5. Here we can see there are 4 ways to manage a virtual cluster. Okay, first one, you can use a guest based manager. You can use a guest based manager, in the sense by which the cluster manager resides on a guest operating system. In this case, multiple virtual missions from a virtual cluster. For example, we can take OpenMosix. It is an open source Linux cluster. It should be running with different guest operating systems on top of the Zen Hypervisor. And we want to go for further example, that is nothing but Sun's cluster Oasis. It is an experimental Solaris cluster of virtual missions. It should be supported by a virtual mission software and virtual mission monitor. And second one, we can say you can build a cluster manager on the host system. The host based manager supervises the guest operating system and can restart the guest system on another physical mission. Okay, in the sense, a good example here, virtual mission software, that system can restart a guest operating system after failure. There are include here these 2 cluster management systems are either guest only or host only, but they do not mix. Okay, and then we can see a third way to manage a virtual cluster is to use an independent cluster manager. In the sense, third way we want to manage a virtual cluster is to use an independent cluster manager on both the host and guest operating systems. Okay, this will make you the infrastructure management, it should be more complex. And finally we can discuss the fourth one here. You can use an integrated cluster on the guest and host operating system. You can use an integrated cluster on the both guest and host operating system. This means that the manager must be designed to distinguish between virtualized resources and physical resources. Okay, so we can see some various cluster management schemes here. Okay, what does exactly here in the sense, virtual missions can be live migrated from one physical mission to another, and in case of failure, and one virtual mission can be replaced by another virtual mission. Virtual clusters can be applied in computational grids. Okay, can be applied in computational grids, and cloud platforms and high performance computing systems. So the major attraction of this scenario is that virtual clustering provides the dynamic resources that can be quickly put together the user demand or after a node failure. Okay, in this system we can say, in this particular virtual clustering plays a key role at cloud computing. When a virtual machine runs a live service, it is necessary to make a trade-off. Okay, to make sure that the migration occurs in a physical manner that minimizes all three metrics. Okay, and we can see the graph here. What does here explains you that the figure illustrates you it affects on data transmission rate of a virtual mission migrated from one failing web server to another. Here we can see this is the throughput, number of data bits transfer per unit time. Okay, and coming to the seconds, the elapsed time. Okay, here what that the effect of migration on web server transmission rate. Okay, this is the figure representative in the sense, the motivation is to design a live virtual mission migration scheme with negligible downtime, so the lowest network bandwidth consumption possible and a reasonable total migration time. So furthermore we should make sure that the migration will not disrupt you other active services residing in the same host through resource contention. For example, if you can take a CPU and a network bandwidth. Okay, and the motivation is to design a live virtual mission migration scheme with negligible downtime, the lowest network bandwidth consumption, it should be possible, and reasonable total migration time. Okay, we can see before copying the virtual mission with the virtual KB, in the sense kilobyte files for 100 clients, the data throughput was 870 megabits per second. So the first pre-copy takes 63 seconds, during which the rate is reduced to 765 MB per second. Then the data rate reduces to 694 megabits per second in 9.8 seconds for more iterations of the copying process. And finally the system experiences only 165 million seconds of downtime before the virtual machine is restored and at the destination host. Finally, this experiment results shows you a very small migration in a live transfer of a virtual machine between the host nodes. So this is a critical manner to achieve the dynamic cluster reconfiguration and disaster recovery as needed in cloud computing. Okay, Now finally we can discuss the topic here, migration of memory files and network resources. What is a migration of memory? In the sense memory migration, and coming to the one more files, in the sense of file system migration, and we can learn about the network migration. For something brief explanation of migration of memory files and network resources. What does we can say? In the sense, during at the time of clusters, it have a high initial cost of ownership, okay, including space and power conditioning and cooling equipment, and leasing or sharing access to a common cluster. It is nothing but some high initial cost of ownership. It includes something here. It is an attractive solution when demands vary over time. Coming to this shared clusters, it offer economies of scale, up or down, and more effective utilization of resources by multiplexing the early configuration and management systems. Okay, early configuration and management systems. We want to focus on the expressive and scalable mechanisms for defining the clusters for specific types of services, and it should be physically partition the cluster nodes among those types. Okay, when we can say when one system migrates to another physical node, we have some issues here. That is nothing but memory migration, file system migration, and one more concept, network resource migration. Okay, later we discuss in further video. That is nothing but memory migration and file system migration and network resource migration. Thank you, ma.